Assalamualaikum warahmatullahi wabarakatuh. This is the lab report for experiment 1, Marcet boiler by me, Nurul Azwa binti Kamal, A23KT0200. So the objective of this experiment is to observe the relationship between the pressure and temperature for saturated steam. This experiment uses a Marcet boiler, which is going to heat up the water inside the boiler and measure the pressure while showing the temperature of the saturated water. And the scope of this experiment is, firstly, the Marcet boiler assumes pure steam, so pressure must be in absolute terms. Secondly, this distilled water is used in this experiment instead of tap water. And lastly, the Marcet boiler's temperature changes are noted every 0.5 bar, increases up to 5 bar, and then decreases starting from 5 bar until 0.5 bar. So, for the theory and working principle, the Marcet boiler experiment is commonly used to study the relationship between pressure and temperature in a closed system containing a saturated liquid, typically distilled water. Throughout this experiment, we can observe how saturated steam pressure increases with temperature according to the thermodynamic principles of pure substance as referred to basic thermodynamics. Thermodynamics property of a pure substance could be determined by two of the following characteristics: T, P, H, S, and V. Data characteristics could be obtained either from experiments or equation. Among two thermodynamic properties that easily measured are T and P. The measured value of the slope of a graph, which is dt over dp, can be obtained from the data of result from the experiment done and compare it with the corresponding values calculated from the steam tables. So here is the formula, which is dp over dt saturated equals to T Vg minus Vf over Hf minus Hg, where Vf is volume of water, Vg is volume of steam, Hf is enthalpy of water, Hg is enthalpy of steam, Hfg, which is Hf minus Hg, which is heat dormant of vaporization. So this is the apparatus setup for this experiment. Firstly, we have safety valve, filler plug, overflow valve, heater, drain valve, manometer, boiler with insulating jacket, temperature gauge, heater switch and master switch. So the procedure or the methodology of this experiment is, firstly, open filler plug using a spanner and overflow valve. Secondly, fill water into boiler until water flow out from overflow valve. And thirdly, close filler plug, which is tighten it using spanner. Next, turn on main switch and heater. And then, once temperature reach about 97 degrees Celsius to 100 degrees Celsius, close the overflow valve. Then, record the initial temperature at 0.5 bar. Then, record the increase in temperature for each subsequent pressure increase of 0.5 bar until the pressure reaches 5 bar. After that, switch off the heater and record the decrease in temperature for each pressure reduction of 0.5 bar until the final reading at 0.5 bar. Lastly, turn off the main switch. So the result asks us to firstly draw the graph of pressure, P bar versus temperature, T for the heating and cooling processes, and determine the slope of the graph. Secondly, we need to calculate the value of TVG over HFG using table 3.1.2, which is saturated water steam, and compare with the slope of the graphs that you obtain in 1. So the graph 1 shows the heating process against pressure. So the graph's behavior for heating process, temperature and pressure shows that it is nonlinear. The R square explains the closest trend line to the data. If it is close to 1, meaning it matches the data trend. So for heating process, as shown, the R square is 0.976, which is almost matches the data trend. Graph 2 shows the cooling process against absolute pressure. So the graph behavior for cooling process, temperature and pressure shows that it is a non-linear graph. The R square explains the closest trend line to the data. If it is close to 1, meaning it matches the data trend. For cooling process, the R square is 0.9591, which is almost matches the data trend. So this is the value of DVG over HFG as calculated. So these are the calculation applied to determine the measured slope. So to determine the measured slope at P2, firstly we need to times the mean of temperature at P2 minus mean of temperature at P1 over P2 minus P1 times 100 kPa over bar. So for example, at 2 bar, the measured slope that we can calculate is 0.173 degrees Celsius per kPa. In order to calculate the calculated slope, first we need to find the value of Vg and Hfg that are not in the steam table via interpolation. And secondly, the unit for pressure and temperature are converted from to kPa and Kelvin. And when we insert it into the formula, we can get at 150 bar, the calculated slope is 0.220914391 Kelvin per kPa. So the discussion of this experiment is firstly, during this experiment, it is observed that the temperature inside the boiler increases as the pressure increases, and vice versa, the temperature inside the boiler also decreases as the pressure decreases. Graph 1 and Graph 2 shows that the temperature during the heating and cooling process vary with pressure of the boiler. The relationship between the temperature during heating and cooling process and absolute temperature as obtained from the graph is directly proportional. And as the measured slope and calculated slope obtained from the experiment are closely matched, this experiment data highly aligns with thermodynamic principles like ideal gas law, which is PV equals to nRT. So the conclusion that we can get from this experiment is from the table of result and plotted graph of pressure against temperature, the measured slope is slightly different from the calculated slope. This might be caused by several errors that occurred during the experiment. So the safety procedures that we must ensure throughout the whole experiment is firstly, wear a lab coat and covered shoes to protect body and feet from potential hazards. Secondly, avoid touching the boiler when it is heating as hot surface might cause burn. And lastly, inspect the unit for leaks as potential water damage and an electrical hazard might occur. Thank you.